Today we will going to discuss about design thinking based aircraft engines. Basically, we know about that classifications of engines and principles of engines. The principle of engines means it means the fuel energy is the input. It's converted into any type of work that is called as mechanical energy, and finally that mechanical energy is converted into electrical energy. This is the basic principle of any type of engines. So from this category, today we will discuss about of aircraft engines. Basically, the aircraft engines are under the category of gas propulsion. Gas propulsion and aircraft engines depend upon the Mach number. It will be categorized into turbojet, turbofan, turbo shaft, and turbo shaft. That is a type of aircraft engines. So you have to now will share about design thinking based category is in turbofan engine.
Hello everyone, I'm Ryan from aerospace department. Before we were going into a turbofan engine, which we know the history of engine, the first gas turbine engine was LE-178. It was built by Germans. It was the first which used gas turbine to propel jet engine. So at that time it was very small jet, so it did not need much thrust to propel. But in our area, in our present day, our commercial airline is a big one. So we need a huge thrust to push the aircraft forward. So in order to attain that,
in this chapter, what is the difficulties or what is the empathy for in that aircraft, particular aircraft?
Thrust to weight ratio. So we need a huge amount of thrust to weight ratio. So in the early aircraft, if there is a small amount of thrust to weight ratio, it is enough for the aircraft. But for a large commercial aircraft, the thrust to weight ratio must be much higher. So in that case, we need to upgrade our jet engine to a little modification. Then there comes turbofans. So the turbofans work same principle as a jet engine, but only difference is we keeping a big fan engines. So there is a more air and going to the engine. So in that case, a huge amount of thrust will be provided.
So this is a defined part.
Defined.
So what is that any type of idea to increase the thrust in that particular engine?
In ideate part, the thrust is very much needed. Weight to lift ratio, the bypass air passes through it. For jet engines, it produces high thrust, but doesn't for passenger plane. In passenger plane, it need a high weight to lift ratio. For that, they modified the jet engine into turbofan, which has a front big fan. Some air passes bypass and some air passes engine core.
So this is an any type of in this case study is it cargo for cargo or a passenger or any commercial aircraft?
It is for commercial and cargo planes.
So why it goes to the any type of other type of categories? For example, militaries or something else. It is apted or not apted for that?
For military purpose, jet engines were we use. For cargo and commercial purpose, we need noise reduction for passengers' comfort, and it needs a long duration, which means fuel efficiency. Compared to jet engines, turbofan has high fuel efficiency, which were used for commercial and cargo purpose.
What is the any type of prototype additional components to increase the thrust? These categories.
It has two. One is a bypass air and complexity of adding internal fans. Internal fans should be modified and propeller should be modified, which has a less drag.
It will be producing less type of a drag.
Yes, sir.
Okay, this type of components in bypass air. What is a bypass air? What is mean definition of bypass air?
Bypass air means which passes side of jet engines.
Okay, there will be any additional component to reinsert this bypass air to that main type of engine section. Or any components are used because of bypass air means that is a additional and extra type of air.
Yes, sir.
Okay, so this is the case study and design thinking based approach for this turbofan engine. Thank you.